Welcome Algebra 2, this is section 4.1, Quadratic Functions and Transformations. The essential question is, what are key parts on a graph of a quadratic function? Let's begin. So this is a quadratic function. I might have done this before. The parent function, which is the simplest form, is y equals x squared, and this is the graph of that. Key parts of the quadratic function, we have a vertex. It's the maximum or minimum point, and in this case, it's going to be at 0, 0. It's the lowest or highest point on the graph. Axis of symmetry is another key point, and that's going to be a line that divides the parabola in half. This shape's a parabola, and it goes straight through the vertex. So a line straight through cuts it in two equal pieces. Quadratic functions can be written in two forms, a standard form and a vertex form. This lesson focuses on vertex form. Standard form is going to be tomorrow. Some key things about vertex form. Vertex form, we got an h and a k right there. That hk is actually the vertex of the graph. The h is the x value and the k is the y value. So in this case of this graph on the right here, it's right here, y equals 2 times the quantity x minus 3 squared minus 5. The vertex is going to be basically the opposite of this number in here, so positive 3, and then whatever number's on the outside, negative 5. So it'll be this point right here that's at 3, negative 5. Another thing about the vertex is that a coefficient. The a coefficient stretches and compresses the graph. So if a, absolute value of a, is between 0 and 1, so it's like some fraction, it'll compress the graph. That makes it smaller or fatter. So in this case, y equals 1/4 x squared. This graph's a little wider than usual. If the absolute value of a is greater than 1, it stretches the graph taller. So in this case, y equals 4x squared. This graph looks a little taller. Other things about that a, it reflects the shape of the parabola, or it flips it. So if a is positive, a is greater than 0, that's positive. The graph, it goes upward, so it forms like a U. If a is less than 0, so it's a negative, it's going to go downward. It's like a sad face, so it's going to go down and forms a mountain. And the top's going to be right there. Alright, other things about a graph of a parabola. Translations of parabolas. We did this with absolute values before, but now this is parabolas. So translating this, the vertical translation, that's translating up and down. To translate, you just change the k value on the outside. So for example, if you have a positive k value, the graph is going to move upwards. In this case, y equals x squared plus 2, the graph is translated up. If that k is negative, in this case minus 2, the graph is translated down. So minus 2 means everything goes down 2 units. Next one. Alright, we also have horizontal translations. Horizontal translations are when you change the h value. So, for example, in this case of x minus 3 squared, h is positive 3 now, so we're going to shift it to the right, positive 3 units, going to the right. In this case, x plus 3 squared, h is actually equal to negative 3 in this case, because it's minus and negative, so you move it to the left 3 spaces. So horizontal moves left and right. Alright, how do we graph a quadratic function? Here's the steps you could follow. First step is I want to plot the vertex and draw it, and then draw the axis of symmetry. So in this case of this example right here, my vertex is going to be hk, and my h is going to be 3, and my k is going to be 1. So I'm going to plot that vertex 3, 1, just like this, and I'm going to label it 3, 1. And then I want to draw an axis of symmetry through it. So that's going to be a dotted line straight up and down, just like this, axis of symmetry. So straight through that line at 3, we can even label the axis of symmetry x equals 3. Alright, so done. This next step is I want to plot 2 points on one side of the vertex. So I'm going to just pick 2 points. I'll choose the left side of the vertex. So the way you want to do this is use a table. So I'm going to use this table below. I've already plotted 1 point, which is going to be my vertex 3, 1. So I want to pick 2 values to the left. I'm going to choose 2 and 1 for x. So I'm going to pick values 2 and 1 for x. And now I've got to figure out what the corresponding y's would be. So to figure out those, you plug it into the equation. So to this equation right here, if I plug in x is 2, I get y equals 2 minus 3 squared plus 1. That's going to equal 1 plus 1, because negative 1 squared is 1, which is going to be 2. So if x is 2, y is 2. Now if x is 1, let's plug that in. You get y equals 1 minus 3 squared plus 1. So that's going to be negative 2 squared, so 4 plus 1. And that's going to be 5. So if x is 1, y is 5. I'm going to plot both those points. Plot 2, 2 right here and label it. And then plot 1, 5 right here and label it. Alright, now that you've plotted those points on the table. Now I want to mirror those 2 points on the other side of the axis of symmetry. So that's the point of that axis of symmetry. So for example, this point right here is just 1 space to the left. Well, guess what? The mirrored version is going to be 1 space to the right. So I plot a point right there and I label it 4, 2. Over up here, this is 2 spaces to the left. I'm going to go 2 spaces to the right and label that 5, 5. So now that I have all those points, I mirrored the 2 points. And with this parabola, you have 5 points. You need to have 5 points to get a good curve on this. So now I sketch the curve. And you just go through it, make sure you go through all the points. Make sure it kind of has a U shape to it. Don't make it straight lines. Do as best you can. That's pretty good. Make sure you have the arrowheads on both sides that indicate it keeps going on forever. And that's the sketch of that graph. All right, let's try some examples. So pause the video. Okay, so the first thing I want to find out is the vertex. So I'm going to figure out my vertex. My vertex in this case, since that's -1 and that's -1, vertex is going to be +1, -1. So I'm going to plot that. +1, -1 is going to be down here, and I'll label that 1, -1. Now the next step is I got my axis of symmetry. So I'm going to do my axis of symmetry. It's going to be up and down right here. I'm going to draw this perfectly dashed line. Axis of symmetry should be dashed because it's not what you're actually graphing. So I got that axis of symmetry. Next thing, I want to plot 2 more points. So I make my XY table. I know my vertex is 1, -1. I'm going to plot 2 points. I'm going to pick 2 points to the right this time. So I'll pick 2 and 3 for X. If I plug 2 and 3 in, well, if I plug 2 in, I'm going to do the work over here. I'm going to get 2 times 2 minus 1 squared minus 1, which is going to equal 2 times 1 squared, so 2 minus 1, which is going to equal 3. So if X is 2, Y is 3. Now if I'm going to plug in 3 for X, I get 2 times 3 minus 1 squared minus 1, which is going to be 3 squared. 3 minus 1 is going to be 2 squared, so 2 times 4 is going to be 8 minus 1, which is going to be 7. So put in 7 right there. Now I want to plot those points. So I'm going to plot the first point, 2, 3, right there. I'm going to label it 2, 3. And the second point, 3, 7, so 3 and then up 7. It's going to be right there. Now that I got those points labeled, I want to mirror it on the axis of symmetry. So I'm going to plot a second point over here and label that at 0, 3. Another point over here, going 2 steps off, and that's going to be at -1, 7. All right, got those 5 points labeled. I can draw my parabola right through that. That's okay. You can do better than me. It wasn't really that good. All right, pause the video. Okay, so how is each graph translated from the parent? You're not actually graphing it, just explain how it is. When you have a -5 right here, that means it's going to be horizontal. It's going to be a vertical change to go down 5. So I'm going to write down 5. That's it. This one, this is going to be the horizontal change, and since it's -4, it's actually going to move it to the right. So right 4. It's kind of like the opposite. That's the positive direction. That's what it ends up being for the horizontal translations. All right, next one. Pause the video. All right, so I got to find a bunch of things. So the first thing, got to find the vertex. Vertex is going to be +4, -2. Axis of symmetry, I'm going to abbreviate it AOS. This is a line at x equals whatever the x value of the vertex is, so x equals 4. Let's see, next one, maximum or minimum value. So that's basically at the vertex. The maximum or minimum, this is actually going to be the y value at the vertex. So the maximum value, or minimum, whatever that is -2. Now let's talk about the domain and range. So domain of any quadratic function. Domain is all x values, and if you have a general shape that goes out to left and right forever, domain is going to be everything because x is always increasing and always decreasing. So I'm going to say domain is all real numbers, or ARN. Now for the range in this case is all the y values. So what you have to do is you start at the vertex. What's the y value at the vertex? -2. Let's see, if I did a y value at the vertex is -2. So you might have to sketch this a little bit. And the neat thing is we can just kind of do the sketch. If I know my vertex at 4, -2, that's about right here. If you have a positive a value, I know my graph, my parabola is going to look something like that. That's not a perfect drawing to scale, but I can see that y at -2 is the lowest value, and then it's all y values above. So the range is going to be y is greater than or equal to -2. That's it.